Let's do some more examples of naming branched alkanes. In an earlier video, I laid out the rules and the steps for naming branched alkanes. I'll refer you to that video. The first step is to identify the longest continuous carbon chain. I'll start at one end and start counting the carbons. Here's 1, 2, 3, 4, 5, 6. And then you notice that the chain continues going up and continuing across. So I have a choice to make. Which way do I go? If I go upwards here, this will give us 7, 8, and 9 carbons. Here's another chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another 9 carbon chain. There's an even longer chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have another choice to make. I can go down with one carbon or go across for another carbon. This is symmetrical, so it doesn't matter. You can pick either carbon. I'll go ahead and count all the way across. And so interestingly, right through the middle here, we have the longest carbon chain. 10 carbons is decane. What we want to do next is identify the substituents. There are some groups that are branching off. Right here, we have this end of a line. In the line bond structure, this end of a line is a single carbon with 3 hydrogens. This is our alkyl group, methyl. Branching off here, we have a corner and then the end of a line. This is a 2-carbon substituent. This is the ethyl. And then branching off here, we have an interesting case where we have branching within the substituent. So this is one of those special substituents. It's a 4-carbon substituent, 1, 2, 3, 4. So this is called a butyl. However, you notice that the parent is bonded not to one of these end carbons or primary carbons. It's actually bonded to the second carbon. And this is a secondary carbon on the butyl group. So the name here is actually secondary butyl or sec-butyl. The next step is to number the parent chain. And the reason we want to number the parent chain is because we need to assign locants to each of the substituents. We need to tell the reader to which carbon atom in the parent are these substituents bonded to. We want our substituents to have the lowest locants. So obviously, I'll start on the left and call this carbon 1 and carbon 2, because that's going to give me my substituent at the lower number carbon. You can imagine if I start on the right-hand side, then my first substituent isn't until carbon number 6, going from right to left. So going from left to right makes the most sense. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here we'll have a 4-ethyl, a 2-methyl, and then the sec-butyl is at position number 5. To name the alkane, we want to use the alphabetical order rule. We'll name the substituents first in alphabetical order. Important rule here, secondary or sec is a prefix that is added by us to identify the butyl group. So for alphabetical order purposes, B in butyl goes first. Then ethyl, and finally the methyl. Without any spaces, we'll add the parent name. The name for this alkane, 5-sec-butyl, 4-ethyl, 2-methyl, decane. Here's another example of naming a branched alkane. Again, first step is to identify the longest carbon chain. I'll start at this end here. I'll start with 1, 2, 3. I have a choice to make. I can go up with these two carbons or continue going across. Clearly, I'll continue going across for the longer carbon chain. So from 3, I'll go to 4. Again, this is only one carbon. I obviously have to continue going across. So here's 5, 6. I can go down here for 2 more carbons or continue going across. Clearly, I'll continue going to the right-hand side. 7, 8, 9, and 10. So right across here, I have a 10 carbon parent. And as we just saw, this is a decane. Let's identify the substituents next. A 1 carbon substituent is a methyl. Here's another methyl group. Branching off of the parent at the top here is a 2 carbon alkyl group. This is the ethyl group. And interesting, right here we have the 3 carbon substituent. So this is a propyl. However, you notice that the propyl group is bonded through that middle carbon of the 3. So because it's bonded to this secondary carbon in the propyl chain, this is actually called an isopropyl. And unlike our previous prefix, iso is part of the name. So here we would use I for our alphabetical order rule. But before we get there, let's number the parent chain and identify the locants. To number the parent chain, we want our substituents to have the lowest possible locant. So clearly we'll start from the left side and count going right. Our first substituent is at carbon number 2 here. If we were to start on the right-hand side, you would notice that our first substituent would appear at 1, 2, 3, 4, and 5. So clearly 2 is better than 5. So right here, we'll go 1, 2, 3. So we have methyl groups at carbons 2 and 4. We've seen this before where we have multiple substituents or multiple alkyl groups that are identical. And so here this would be a 2, 4, and we have to tell the reader this is a dimethyl. Here we would have a 3-ethyl and a 6-isopropyl. For alphabetical order rules, the prefixes di, tri, and tetra, etc. are not part of our alphabetical order, so we'll use M for our alphabetical order rule. So let's put this together. E would go first, 3-ethyl. I would go next, and our methyl groups would go at the end here. With no spaces, we'll add the parent.